Thank you.
the speakers of our webinar today for giving their busy time for our students. I hope students will also get some ideas about smart industries, its technology requirement from this webinar, and interact with the eminent speaker to make this webinar truly live. Again, I want to congratulate a member of the Computer Science and Engineering Department for organizing such webinar and wish the success of this program with the active participation of them. Thank you. Thank you all.
Thank you, sir. Thank you for your valuable presence in this webinar. Now, I would like to request our HOD, Dr. Saurabh Dey, to say something and also to introduce the today's speaker. Okay, Dr. Saurabh Dey.
So, good morning, dear participants, the honorable speaker, Dr. Rick Das, my dear colleagues, and Dr. Gautam sir. It is a great pleasure for me to extend to all of you a warm welcome in this one-day international level webinar on adoption of disruptive plan for Industry 4.0, bridging industry academia gap on behalf of Department of Computer Science of Engineering of which we are Engineering College. It is organized in technical collaboration with IEEE Young Professionals, IEEE Kolkata section. It is an honor for us to organize this webinar. To become a center of excellence, our Computer Science Engineering Department has taken this initiative. As we know that the whole world is moving through a pandemic situation, under these circumstances, it is very hard to conduct a seminar physically. In this webinar, there are two sessions. In the morning session, we have Dr. Rick Das with us to make this webinar a grand success. Dr. Rick Das has over 16 years of experience in academia and research with various leading universities and institutes in India. He is currently associated with Xavier Institute of Social Service, Ranchi. Dr. Das is recently appointed as a distinguished speaker of the Association of Computer Machinery, ACM, New York, USA. He is featured in Lukett's Walls of Fame as one of the top 10 tech-savvy academicians in higher education across India for the year 2019. He is also a member of International Advisory Committee of AI Forum UK. Dr. Das is the recipient of the prestigious Insect Research Excellence Award hosted in the year 2020. Dr. Das has carried out collaborative research with professionals from industries like Philips Canada, Cognizant Solutions, TCS, and so on. Dr. Das has filed and published 2 Indian patents consecutively during the year 2018 and 19, and has over 24 international publications till date with reputed publishers like IEEE, Springer, Inner Science, and so on. He has authored 2 books in the domain of content-based image classification and has edited 3 volumes with IGI Global, CRC Press, and DODR Germany, respectively. Dr. Das runs a YouTube channel named Curious Neuron to disseminate knowledge and information to larger communities in the domain of machine learning research and development and open source programming language. Dr. Das is always open to discuss new research projects or ideas for collaborative work and for techno-managerial consultancies. Thank you, Dr. Das, for giving us the opportunity and gave your consent to hear as an expert speaker. Hope all of you will enjoy this session. I am requesting all of you, please start up the audio and video during the session for the smooth running of the session. In the addition, please do not use the platform for personal discussion. If you have any question during the presentation, please type them into the chat box. We will bring them up after the presentation and we will have the time for questionnaire session at the end. Thank you. Now, we are handovering the mic to Dr. Das. Dr. Das, please start your session.
Thank you, Dr. Saurabh Dey, for your wonderful presentation as well as introduction. I'm really indebted to your kind self for such a nice explanation of whatever I have done till date, and also for the necessities and requirement of setting up a webinar like this in current context. I would like to express my gratitude to Dr. Prabal, the principal of CGEC, for encouraging such an initiative. At the same point of time, I am thankful to Dr. Gautam Das for setting up the context and pointing out the necessary points as the necessary areas in which one needs to concentrate for advancement in his or her career as a student and also as a professional. And I am also delighted to get introduced to Professor Das in this platform, online platform, glimpse of his immense expertise. I am equally thankful to Dr. Sudip Adhikari for initiating the session, for making us aware of the aims and objectives of this particular session, and correctly setting up the context for the today's webinar, international webinar, respectively. I would take this opportunity to thank the entire initiative of CGEC along with IEEE Young Professionals in collaboration with. We are being able to exchange our thoughts in this platform where we even unknowingly coming in touch with each other, getting a scope of sharing our ideas and vision so that we can jointly experience the disruptions which are happening these days. Well, already being introduced, and I'm just now trying to share my.
হ্যালো।
হ্যাঁ, মিটিং ক্লোজ হয়ে গেল নাকি?
না তো, আমি তো এতেই আছি।
মিটিং চলছে?
মিটিং তো চলছে, এই যে আওয়াজ দেখো।
আচ্ছা ঠিক আছে,
এই
ওকে
যে না,
ওকে।
এই একটা কথা, সেটা হচ্ছে যে কোনো চ্যাট ফ্যাট কিন্তু আমি খুঁজে পাচ্ছি না। কোশ্চেন ফোশ্চেন কেউ কি এখনো করেছে?
না না, সেগুলো পরে দেখছি ওটা। আমি এখন একটু দেখি ইউটিউবের ওটা, ঠিক আছে?
আচ্ছা, তুমি দেখতে থাকো।
ঠিক
আমি
আছে,
ওই
হ্যাঁ
গুগল মিটে খুলে রেখেছি, গুগল মিটে
হ্যাঁ,
রানি।
ঠিক আছে।
এমনি
মেটেরিয়াল ঠিক আছে কিন্তু তো তোলা তুলে নিয়ে গেছে তো কনসিলের পাইপ টাইপ সব তুলে নিয়ে গেছে ইলেকট্রিকের যত কাজ সব তুলে নিয়ে গেছে একসাথে আর একটা ফ্লোরে আর তোর নিচের থেকে তো মার্বেল সেগুলো সব তুলে নিয়ে গেছে
So, as being rightly pointed out by Honorable Dr. Dev, the theme of this session, it is basically on image data perspective of different aspects of machine learning. I would appreciate if the participants may mute their speakers, otherwise too much of sound is, noise is there. So, I hope my entire screen is visible now. Now, this particular topic, which is an image database perspective on data science, machine learning, and deep learning, I extend my gratitude and I welcome you all on behalf of Xavier Institute of Social Service, Ranchi, which is one of the premier B schools here in India. So, just to give a brief about Xavier Institute of Social Service as an initiation of this particular session. So it has been there since 1955 as one of the Center of Excellence in Management Education, Research, Consultancy and Development Interventions. It is known to all, it is evident to all that Jesuit education, since this is a Jesuit-based school. Excuse me, can I have all the microphones muted? I would request Dr. Dev to kindly mute the microphone. Hello. Yeah, thank you. So I was saying about the genesis of XISS. XISS is, as evident, quite evident that it has been there since 1955, and it is a center of excellence, as I was saying, and it is a Jesuit-based school run by the Jesuits. As you all know, that Jesuit education dates back to 1534, and it is always known for its academic excellence and innovation. True to its name, Xavier Institute of Social Service stands tall on excellence in management education, research, consultancy, and development intervention. It seeks to develop the whole student, not only in terms of academics, but also intellectually, morally, and spiritually. That is why in the process we value social and environmental justice, interreligious understanding, and service to others, especially the poor and the marginalized in the society. We prepare students for a lifelong learning. To be successful in our mission and to aspire, we do follow strictly 6 different values, which initiates with MAGIS, which means more, that means striving for excellence. We do not differentiate men and women, and we try and attempt to maintain harmony in men and women for and with others by sharing gifts, pursuing justice, and having concern for the poor and the marginalized. That's why we believe in cura personalis, which means it caring for the individual person, respecting each person as child of God and all as God's creation. We believe in uniting heart, mind, and soul for developing the whole person and integrating all aspects of our lives. That is why our spirit lies in ad majorem Dei gloriam. That is for the greater glory of the God. All our services we mean for the greater glory of the God. That is why we believe in forming and educating agents of change. That is, we believe in teaching behaviors that reflect critical thoughts and responsible actions towards the society. We are having 5 different disciplines, in fact, that is HRM, marketing, finance, rural management, and information technology. Our institute is headed by Reverend Father Dr. Joseph Marianus Kuchur and the Assistant Director of the particular phrase has gone cliche these days because all of us are aware of this. We are experiencing the VUCA world, right? So what do we understand by VUCA? It stands for volatility, uncertainty, or unadapt. Really cope up with the ever evolving changes that happens every moment. So whatever we see around us in these days are considered as data. So whatever it is, so data is now considered in all forms. So you name anything and that can be considered as a data. So what is the reason of enterprises for collecting so much of data? That is because of framing questions for that particular data. So one may require to understand that which of the customer segment is more profitable and how to reduce the customer acquisition cost. So there can be several ways in which data can be questioned and a data can provide you insight. Now, one question essentially leads to the other. There is no dearth of questions, right? So one can frame one particular question for a data, and from that particular question, it may give rise to another question, and it also gives rise to the next question. So you can go on asking questions to the data. Some of the potential questions are given here in front of you as I'm sharing my slide. And the vision is to drive the business with efficacy from rich data-driven insights. So data is there with everybody. It is with you, it is with me, it is with all the rich businessmen and people over there across the world. But then we need to understand one thing, that the insights that we draw from that particular data is not the same. Obviously, if it had been the same, then all of us would have been equally successful in exploiting and exploring the data, which is not the case. So that is why we need to understand the meaningful insights from data, which calls for optimization of insights. Now, if we look for optimization of insights, which means that I may look at a particular kind of an insight with some kind of a mindset, which will essentially differ from the one who is having rich experience and exposure to those kinds of insights for such a long time. Let's say the person is taking those kinds of insights for the last 20 years, and I'm evaluating for the last 5 years, 4 years, 3 years for that matter. So when it comes to analytics, some questions can be poorly phrased, ill-conceived, and misguided. Now what happens that, as I told already in the last slide, that there is no end of asking questions to data, but then the point is that the time for insight, the time for decision making, the time for competition in the market is limited, that one has to understand, right? So probably many of us have experienced, many a times that whenever we do research, especially in academia, although the scenario has changed a lot, in fact, I will say drastically with the introduction of Industry 4.0. But then, of late, if you have a look at the academic research, and if you take this academic research to the industry, people in the industry are not really interested in that. I mean, in most of the cases, of course. Now, what is the reason behind that? Mostly, the people in the industry do have a notion, do have an idea that see the people who have done an academic research, or even if I can rely on this person for a particular project with a deadline, the person may not be able to meet the deadline because that with a deadline, the person may not be able to meet the deadline because that infrastructure or potential, let's say, I will not say potential, but that infrastructure is not supported in the framework of academia of target-based, let's say, work, right? Now, what happened with time that, as you can see, that is why I have written here that there are no end to question, but the time and resources to find the answers are limited. Why? Because someone is paying for your time. Someone is paying for your resources. You have to understand that. I mean, anyone here who will be, eager to pursue a research in whatever form it is, in whatever way of data it is, one needs to understand that it is not to my sole property to carry out the research. Why? Because someone is investing his or her time, his or her effort, his or her money, his or her funding. So based on that, one needs to be cautious enough one needs to be understandable enough to understand and to comprehend that the time and resources to find the answers are not unlimited. So you have to be very, very strategic right from the beginning so that you can lead it to something which is tangible. Because you see, you can, you may tell me that you may, differ from me by saying that, you see, research cannot happen like that. The thing we need to understand that most of us, if not all of us, of course, not all of us, because there are people who are doing other kind of things. Why I'm saying other kind of things? Because in fact, we are all doing let's say applied research, not the fundamental one in most of the cases. So the fundamental one research, that is the fundamental research as we refer to them, is, let's say, inventing the gravity, inventing the buoyancy and stuff like that. But then mostly what we do, we take a base paper, we take an existing work, we do an extension on it, right? So while we are doing that, mostly we are doing applied research. We are taking this thing forward with some new contribution. Now, this is more of an optimization than finding out something which is very novel, very new, which has not been done anybody earlier. So that is highly arguable, that is highly questionable. So one may require an entire lifetime for generations, probably proving a particular concept in fundamental research, which is not the truth. Because let's say if you are even doing a PhD, you have to take a readmission, or you have to make a this kind of stuff, readmission kind of stuff. If you cross 5 years of career registration, that means there also you are having a specific time frame. So why not in the research? Because in the applied research, especially when you are doing it now, if you are just doing it for the sake of doing research, for the sake of publication, that is a different issue altogether. If you are again doing it for the sake of contribution to the society, then there is a different perspective. For the sake of collaboration with the industry in designing a solution, then there is a different perspective. So that is why the meaningful insights from data to be accessed, that requires a specific kind of strategization, expertise, as well as planning. You cannot just go on asking questions to the data, but, for generating insights. The time is limited. That you have to always keep in mind. The question which eventually comes up, that whether if data science is synonymous to machine learning in all these things. So while I'm talking about data, while I'm talking about research, so most of the research these days are guided by or are eventually being, let's say, initiated or encouraged by this data science and machine learning. You name any field, wherever you just bring in some kind of data science stuff, machine learning stuff, it becomes some kind of a research which is highly in demand. And these days, even quantum machine learning, and if there is a term of quantum in that, so that becomes even more acceptable. So why am I saying this? Because the data science and machine learning, these two terms are not synonymous, right? So data science especially deals with the descriptive analytics of the data, and machine learning is more of a predictive analytics, right? So while you are doing a data science kind of a scenario, probably, let's say if you are trying to find out what is the, let's say, area of an apartment, or let's say what is the how many balconies are there in an apartment, how many, let's say, bedrooms are there in an apartment, where it is located. That is probably a data science approach. If you think of image data, if you try to find out that what are the distributions of different colors in data, color levels in data, what are the different distributions of pixels or gray levels in data, or what are the different types of textures and what are the repetitions in data, that probably leads to data science, right? And that is not really dealing with machine learning. Why? Because this is something, the data science is something which comes to the pre-processing stage, and a machine learning is something when you try to predict the price of an apartment, when you try to predict the class of a particular image, then it comes to machine learning. So right in the beginning, right in the inception, we need to be very clear about our concept, that what exactly data science and machine learning stands for, and whether they're synonymous or not, which is not the case. So as we all know, that a picture is worth 1,000 words. Why? Because it embraces plethora of complex technical tasks to handle an image, and the process uses image as input to gain insights out of the image. Now, gaining insight just doesn't mean that to understand and identify the category of the image or to cluster it that. You can also gain insights of the image by understanding its orientation, by understanding its, let's say, different distributions of different values inside it, by understanding the nature of the image, by understanding the source of the image. So there can be so many ways by understanding the dimension of the image, and each of these are essential if you are going to process the image with the help of whatever resources you are having. Because one thing we can and we must understand in this current context that many of us are working in different institutions, not I will not say in industry but in institutions, and many of us restricted environments in terms of research. Now, restricted environments, when I say this, it means in terms of infrastructure that is available for us to do the research. Now, at times, you may not be having that kind of an infrastructure where you can do the research smoothly in terms of, let's say, the kind of investment IITs can do for, buying big lab setup with GPUs and all these things. For any, random engineering college or any random B schools or like that, it is not really feasible. I won't say possible because it is always possible, but then it is not feasible because that is not their aims and objectives, right? So we need to understand that within that is the most important skill that one needs to gain, especially with image data, because usually they are very, very rich in context, and you most of the times you require huge processing power for this. So we need to understand that how within restricted environment we may be able to handle image data. Hello, am I audible to you all?
Yes.
Yes, yes.
Okay. Yeah. So we need to understand that how we need to handle this kind of rich data within a limited or given amount of infrastructure. So for that, all of us are by and large aware these days. We are having Google Colab, we are having let's say Kaggle, all these platforms where we are getting free GPUs. And on the top of that, let's say if we are looking at offerings of open source softwares, mostly that we do, that is probably let's say TensorFlow, Cafe, Piano, and all these things are there, and Python-based several languages are there. But the basic context is that even the good wrapper like Keras is also available. So what is more important now that we have to understand, because by and large with the platforms of Google, in most of the times we are getting some kind of let's say research for doing good academic research, in fact with the help of free GPUs. Probably it will take a little bit of longer time, but then at the same point of time we need to understand one thing, that how really it is going to help us in terms of let's say doing a credible research. So probably for that collaboration is more essential, because at times if you collaborate with people from academia and industry abroad or here in India, you may scale up your research. That is one. Second is that you get many GUI based things these days, and also some kind of things like, let's say let's take an example of Auto ML, which is there. Let's take the example of Vita, which is there. Let's take the example of Orange, which is there. So these are all GUI based softwares for machine learning. And let's say whatever kind of data it is, whether it is a text data, image data, whatever data it is, you can do all sorts of stuff of machine learning with the help of these GUI based platforms. So that means the creation of prototype is no more an issue where you can test. The more important is the idea generation, that what you really want to do. So there you differ from a normal software engineer as a researcher. So that is the basic identification of a researcher, that I would like to form a prototype just like that randomly because someone else has told me or said me or instructed me, or else I would like to do it on the basis of my understanding, on the basis of my questions, important research questions, which I feel are not explored earlier, and I can do an extension or contribution to that. So the question is, what insights are we looking for? So that's what I was discussing. That is ROI for image processing. That is, ROI means not the region of interest here, but the return on investment. It means that while I'm investing so much of time, energy, effort with image data, can we gain a new insight that can transform a good research finding to a great research finding? So that's what is required for turning a good research to a great research. So that is why I'm using this term investment. That is, what kind of return on investment are we looking for? Usually, let's say, whenever we do an academic scenario of research, we look for a publication either in a SCI journal or a Scopus journal, or let's say a UGC, at least a UGC registered journal. Usually, in case of industry, when we do that, we look for customer satisfaction, which may provide us the lead for the future kind of orders and future kinds of contacts with other prospective clients as well. So then we have to be careful enough to understand that investment we are really looking for in image processing when we talk about images as data. So does it worth being a neophile? So what does this term neophile means? It means nothing, but neophile means the one who is always looking for novelty. So, on a lighter note, whenever you just submit a research or try to do a new work in your MTech or BTech thesis, the professor may ask you that, hey guy, you are doing this, so what is the novelty in this? Or what is the new thing you are doing in this? What is the new thing you are bringing in it? So is it always worth to be a neophile that is always looking for a novelty? Now we need to understand one thing, that what does novelty exactly means in this particular scenario. Doesn't really always mean that you bring something from Mars and implement it here, nothing like that. Or you bring something which is totally, for the first time you're the pioneer introducing that, nothing like that. One form of novelty, but there are novelty when there you can use an existing technique to totally a new domain. That becomes a novelty. You can use a new technique to an existing problem domain. That becomes a novelty. So there are so many ways of designing and defining novelty. It depends on the kind of presentation and on the kind of innovation you are doing. So it doesn't always work to be a neophile. It may also address, some kind of bottlenecks, but technology adoption choices can never be made lightly. Need to understand and we need to identify that in which stage the technology is, whether it is in crawling stage, whether it is in walking stage, or whether it is in running stage. Discuss about these three stages, but then we need to identify that right in the beginning, that the kind of technology we are going to adopt, in what stage it is. So that is why there is a concept which is known as hedgehog concept. So hedgehog is a quickly kind of a small creature which is having spines all over the body. So he is trying to get hold of the hedgehog. The fox is trying to get hold of it, trying to grasp it, trying to act like as if the fox is sleeping, so that whenever the hedgehog comes in close vicinity of it, the fox can grab it and can eat it like that. But then the hold of the hedgehog, why? It gets hurt by the spines or by the different kinds of those pilky spines which are coming out of this hedgehog. So the fox is not really able to get hold of it. So the fox knows so many techniques to get hold of the hedgehog, but the hedgehog knows one big thing, and that too in a very good way, right? So one needs to look at a particular, by this hedgehog concept, what I try to convey to all of you is that we need to look at a particular problem at a very basic level, that is straightforward way of looking at it. Primarily, once we get the basic concept, then we try and we should grill inside more and more to find out the nitty-gritties, the complexities, the different attributes which are more and more crucial in identifying and solving the problem. But then, if we try right in the beginning several kinds of approaches and do not know in depth of any one of them, that is not really going to help us in a long run in terms of research, in terms of exploring the data, in terms of becoming industry 4 adept professionals or professors, whatever it is. So I'm giving you an example. I think, none of us, if not all of us, have heard of this particular VisiCalc term. What is this VisiCalc? VisiCalc is, you believe it or not, was the first major computer spreadsheet program it was. So it has lost its importance to Lotus 1, 2, and 3, version 1, version 2, and version 3. And finally, Lotus is solely replaced by today's Excel, that is Microsoft Excel, right? So it is not always, a great thing to become a pioneer. Who knows the name of VisiCalc? Hardly 1 or 2% knows the name of VisiCalc. Who knows it these days? Who remembers these days? But then sometimes you don't want to run to the next big thing. It's smarter to take crawl, walk, and run approach. So what is crawling? Crawling means when you are experimenting with a new technology internally and creating some prototype and then facilitate a robust debate on its potential fit with your edge of concept. So what is that? Whether with this new technology, which is in the crawling stage, whether you can really move ahead, slowly you can move ahead, you can see the big picture, and then gradually whether you can explore better things with it or not. So that is the crawling. Let's say the stage in which we are in quantum machine learning, for example. What is working? So we begin to integrate the technology with our pre-existing things, right? So pre-existing systems and priorities we need to find out, we need to identify, and then we try to integrate it. We need to ask ourselves that continually that whether the technology is serving our concept or distracting from us from the concept. For example, you are looking for developing an app for a cell phone which gives you prompt response, and you are trying to incorporate continuously neural network into it. Now, is it application is adept enough to get installed in all kind of cell phone, even lightweight cell phones, and can give results, or it is creating a scenario where the entire system is coming to a standstill? But then still, just because of introducing neural network, you are very keen to do this, then it makes no sense. So then you have to do a lot of testing, a lot of optimization, so that it becomes adept to the cell phone platform or scenario. So that is what is the working stage of technology. Finally comes the running stage. Let's say ERP. All of you are aware of what is ERP? That is enterprise resource planning. So enterprise resource planning in its first stage, in its initiation, when it was initiated in early 2000 or even before that, many industries and institutions have adopted this, and immediately they have come to a standstill. Some of them have also stopped functioning, that is stopped execution. They got shut down because of ERP, because they have not considered some important aspects of ERP, some hidden cost of ERP, like the training cost, like the breathing time after implementation, like the different way in which they need to change their business, not the software, so that they can gain insights as well as they can get revenue from that software. So that they have not followed and they shut down. So that time, at that point of time, the technology was in its crawling stage and working stage. But then gradually people understood it, and now people are efficiently using ERP as one of the most significant tools of the industry, and maintaining and observing their entire system. And even ERP is now integrated with all the aspects of AI, machine learning, and stuff like that. And that is why you see it is now in the running stage and it is smoothly being handled. So this is what is the crawling, walking, and running stage of technology that we need to identify and understand before even we go with any kind of data and analysis and exploration of the data. So images are, there is a huge popularity of text-based data. So then how come image comes into the picture? And so why in the first place one will take interest in image processing? Because of the fact it is very clear, as I have already told, that image worth 1,000 words, that is one. These days images are very, very easily available. You look at your cell phone camera and always we are busy in taking selfies and taking photos of different features and environment around us, and whatever things we are visualizing. Even if we look at the notice board today, we do not write to, we do not intend to write the important things out there. We just click a picture and like that. So that is why image data has become very, very popular and very, very accessible, very, very affordable. So that is why images has now become an identity. one more research data which is there is that 65% of us are visual learners, that we learn by seeing, according to the Social Science Research Network, which is also known as SSRN. It is owned by Elsevier, and the 90% of information that comes to the brain is visual. That is also a 2000 research, if you can see. And then 40% of all nerve fibers connected to the brain are linked to retina. That is 40% of the nerves which are there connected to your brain are coming from the retina. That is also research by Jensen, 1996. Yes. Any confusion? Hello. Hello. So easily and so affordably available to all of us. So are these two things same these days? If those who are new researchers, and to them mostly image processing and let's say neural network or deep learning are synonymous, which is although I would say rather very unfortunate, because these two things are not the same. Image processing and let's say deep learning. So how come deep learning comes into picture in that case? On that, there lies the question of making image processing irrelevant with deep learning. So people say that why at all you need to do image processing in the first place when there is deep learning? Does it really carry any sense anymore? That why at all you should learn image processing, why at all you should go for digital mathematical formulas? You just put the data in a neural network and it will do the work for you. So image processing has gradually become irrelevant. That's what is a very common statement which is there in the environment. So let's say what is the significance of digital image processing? The first being the improvement. So there are two types of image processing which we really look for. One is for human understanding, another is for machine understanding. So for human understanding, let's say what you do, you just you use the filters on Instagram, in your let's say WhatsApp and places like that, and editorial also, for making it better understandable by human beings. And the other one is to make it understandable. So where these two things differ, one is that as human being, you look at the entire picture or the entire image, and then inside your body, inside your brain, this kind of processings are going on for in terms of features that how do you recognize. But in machine, you yourself has to identify the features for a particular algorithm so that the image become understandable to the machine. So in these two ways, these the image representation differs from one another. These are some dominant AI applications where, as you can see, that image tagging, bounding boxes, forensic sciences, industrial automation, and then virtual reality playing, game playing, and all these stuffs which are used by one of the dominant AI applications for image processing or IP. So as I was saying about the importance of feature, that is, as you see, everywhere there is feature and feature vectors, which is the basis of image processing, there's machine learning, there's AI. So feature is a very important aspect without which, without robust feature, nothing will become a success. So an amateur probably will concentrate more on, let's say, the post-processing effect. That is, you fine-tune the parameters, and then you find out different kinds of classifier. You get into neural networks straight away and stuff like that. But a pro, that is a professional, usually takes more interest in the optimization of the feature vectors which are being provided to the algorithm for a particular kind of insight to be gained from the image data. So now what exactly do we mean by pre and post processing in the first place? So as I have already told you, that pre-processing is something which understands the orientation of the image, probably in terms of the textures, in terms of the colors, in terms of the energy in the image, in terms of the let's say a different repetition of patterns and textures in the image, by which you define the features of the image in the form of vectors, which are the rows in the Excel sheet where you generate the vectors, right? What is essentially the feature vector which we are looking for. And okay, I'm coming to that a little later. So that is what is the feature vector extraction part, which is the pre-processing part. The post-processing part is when you are putting this feature vector to a particular algorithm for let's say, certain kinds of categorization, certain kinds of prediction, certain kinds of clustering and stuff like that. So even I can tell you one thing, the clustering also becomes a very, very good part of pre-processing in terms of feature vector generation. Let's say if I take the example of vector quantization based techniques. Let's say a good old technique is the Lindenbusov-Gray algorithm, LBG algorithm, where you can genuinely define the code books as features of images, right? So this is what is the pre-processing process. And whenever you're putting this, or you are, allowing this process or allowing these features to be executed on an algorithm like random forest, like decision trees, like let's say SVM, like KNN, whatever it is, or even neural network classifier, then it becomes the post-processing part, right? So these two are clearly, differentiated from one another. Now, the panacea then named deep learning, which is being said as solution to all, that's what the meaning of the word panacea is. And since, I have already mentioned about the age of AI, we tend to automate everything. So that's why to do feature extraction with the help of age-old handcrafted techniques. It is, the AI is there, the deep learning is there. Why not also automate the feature extraction part? So what we do in the first place is that the feature extraction as well. What we do, whatever image data is we just put this, whatever even text data it is, we just put it to a, let's say, deep learning input, and then from there the transfer learning takes place in most of the cases with the help of pre-trained neural networks, and then you get certain kinds of classification results. So that is what is the deep learning panacea, that is cure for all. But then, possibly in recent scenario, image processing and deep learning can hardly be separated from each other, because the feature extraction part is eradicated by deep learning. It is no more required because you are just putting the entire image to the deep learning scenario, right? So what is the quick fact? The quick fact is it requires a huge amount of training data in deep learning in case of pre-trained network. Also, deep learning demands for huge infrastructure, a rich infrastructure, because it is very resource hungry. To understand deep learning in image processing, we need to segregate descriptive and predictive analysis, which I have already told you. That descriptive analytics is more of dealing with the nature of the data, and predictive is to predict that what we can get out of this data. For example, if you are looking the texture, if you are looking the color combination of the image, if you are looking the base colors of the image, if you are looking at color transformation of the image, you are looking at the descriptive analytics. If you are doing, let's say, some kind of prediction, classification, and this kind of categorization with image, then you are looking at the predictive analytics. So one pertains to the pre-processing, the other pertains to the predictive, pertains to the post-processing of the image data. Predictive analytics and deep learning, what has been done with this is that deep learning, which is also a subset of machine learning, rejects the traditional programming paradigm. Why? Because in traditional programming paradigm, you do it in a separate way, the feature extraction, then you do it in a separate way in case of, let's say, classification, you put it through a different set of post-processing techniques and algorithms. But here, when it comes to deep learning, it negates it, the problem analysis part, because you are not at all responsible, everything is automated, and then it is replaced by training the framework. So a training phase is going on, which is there in the deep learning from the feature extracted by it automatically in whatever way it does, just like a black box, and then you get the necessary results. So that is how deep learning has replaced the traditional framework. But then there are certain dependencies which I was saying, that is computing power, memory capacity, power consumption, image sensor resolution, and optics. These are certain, let's say, significant dependencies on device capabilities when you run deep learning for rich insights and rich, let's say, image data. So you can find plethora of cancer image data which are very, very rich and to be dealt in with. So if you are even, the data is already rich, then you are using on top of that deep learning. So the kind of setup that you require, and in most of the cases, right? So there comes the good old feature extraction. That is a handcrafted feature, like say, have some time or the other, you can devise certain kind of problem-specific features, right? So why am I saying this? Because if we look at that, before the emergence of deep learning, this type of feature extraction used to have a huge importance. But then the shift is still there, because let's say that is why I come to this point of representation learning. Whenever we are, let's say, taking out a particular layer of deep learning neural network, let's say the last layer before the classification layer or the softness layer, then what we do, we take it out and then we deploy it as a feature to a different classifier. That is what is the representation learning, or the representation way of representation of the different data that has been put in the particular neural network, which can be well evaluated by even an SVM at the end, or let's say random forest at the end, instead of a normal traditional deep learning classifier. So there you see that even you can use this deep learning network as a feature extractor. So it is not that it has been replaced, but it has been made transparent from the professionals or researchers who are now doing this. But then earlier it used to be very, very domain specific. That is why these are the low level features which we used to say, that the shift surf, or let's say different transformation techniques like discrete cosine transform from first Fourier transform and things like that. There are also top hat, bot hat, this kind of feature extraction techniques for knowing the shape and the size of the images. And there are also GLCMs, that is gray level co-occurrence matrix, for your this thing, I mean texture oriented features. And then there are of course good old binarization techniques, that is the local thresholding techniques, global thresholding techniques like OSTOs, local thresholding techniques like NIBLAC, like Sauvola, and these things were there. But then several CV algorithms such as age detection, coordinate detection, all these like threshold based algorithms which used to be there as feature extraction, they are still there. But then here in deep learning, they are performing with different kinds of filters, these kind of feature extraction, that is still going on. It is not that it is not going on. But then how are we using it efficiently, right? Technique of forming efficient features, as we all know, is to just find out the different ways which we have discussed right now, whether it is using neural network for representation learning or by using handcrafted feature vectors. We can use the bag of words techniques as well. At the deployment stage, these definitions are searched for in other images. And what will happen is that from these features, we will be able to classify the categories of the images with by and large good precision, which is actually attempted or aimed for. Now, what are the bottlenecks in traditional feature extraction? With this traditional approach is that it is necessary to choose which features are important in each given image. So it becomes more or less manual kind of a scenario, which is being eradicated by the deep learning. So that is why it has become very popular. Now, as you increase the number of classes, the feature extraction becomes more and more cumbersome, because you have to also find out the interclass and intra-class separately, right? So that your features do not overlap with one another. It is up to the computer vision engineer's judgment and the long trial and error process which is involved in it to decide that which of the features will be used to best describe the kind of image data which is there in question. And then moreover, each feature definition requires dealing with plethora of parameters. So now in deep learning, if you have a look, that you really do not have to take care of the parameters, because when the pooling thing is going on, when the flattening thing is going on, the deep learning itself is taking the decision. You are not going to choose the parameters for it. So that is why it becomes very, very popular because it has addressed the bottlenecks of the traditional feature extraction techniques. So that is why you see deep learning as the one-stop solution, because it introduces the process or the concept of end-to-end learning. So as I have already told you, that it is already just given a data set and you get the final result. So it happens with the help of training and testing data, and it automatically works out most of the descriptive and salient features with respect to each specific class of or objects of interest, right? In case of deep learning, which doesn't happen when it comes to normal computer vision cases, in case of people who are doing the handcrafted feature extraction. It is very true that with the with the advent of this convolutional neural network, there is a pre-trained convolutional neural network or the vanilla convolutional neural network, which all are there in practice. These are so good for image data, and they have so well established their supremacy that it has become quite a tool for all the engineers to use this particular technique of convolutional neural network, especially for image processing. CNNs, as I have already told you, you use kernels. Now, if you look at morphological feature extraction, there is something called structuring element, right? So with this structuring element, they are used almost like the kernels. In fact, they are nothing but small images of zeros and ones by which you use this erosion and dilation kind of thing. So similarly, in CNNs also, square kernels are used so that you can find out and it is nothing but just a matrix of values and which are called weights, which are trained to detect specific features. All right. CNN, here you are not defining the kernels; they are already defined inside the CNN, so you are getting the advantage right in the beginning. So there lies the kernel trick. Now, the recent obstacles that you might have observed that is being seen in, let's say, this kind of features, feature extractions with CNN, is that the recent problem that we have experienced is that Uh, however, the pandemic scenario, when there is a very lack of training data in case of pandemic scenario, nobody was releasing the training data, image data, or just extra data, whatever it is. So there, since the deep learning do not have enough test data, it was miserably failing and increasing the number of false positives, right? So that is why there comes the requirement of again feature extraction, handcrafted feature extraction. You see the popularity of techniques like zero-shot learning, like one-shot learning, where at times handcrafted feature extraction, a combination of handcrafted feature extraction and the deep learning feature extraction, that is representation learning. So algorithms like SIFT and even simple color thresholding like this. So that is what is coming into actual rescue. So you need to understand and identify that I'm not saying that handcrafted is bad or deep learning is bad or handcrafted is good or deep learning is good. It is nothing like that. It is that you need to be responsible and mature and adult enough to identify that which technique is applicable where for which problem statement. It is not that just for the sake of applying you have applied handcrafted or you have applied deep learning, it doesn't really make sense. Neither it will make a good research to a great work. That is why my suggestion is to act like a pro, that is a professional, and you need to understand that to classify two classes of products on an assembly or a conveyor belt, as an example I have given it, that one with a red bed and the other with a blue bed. You can just use a color thresholding instead of using a deep neural net because that is not required there, isn't it? So, however, the same can be achieved by using, as I told you, simple color thresholding. So, some problems can be tackled with simpler and faster techniques. That is why I told right in the beginning that a K-job concept is very much essential and necessary for us to go ahead in life. So there are several criticisms of deep learning. As we all know, it is being sometimes treated as black box, that nobody knows what is going on inside and what comes out. So that is why many people do often criticize deep learning. But as I have already told you, that you need to understand where you need to apply which technique. That you have to be very confident about. So the positive side of handcrafted techniques are that it has full transparency and you have got full control on the kind of data that you are handling and the kind of features that you are extracting. And if anything fails, the parameters can be tweaked. That is, the parameter can be changed and optimized a little bit so that you can do certain more trials and errors on it. Right. So that is why I have talked about the innovative usage, that you can combine the deep learning and the handcrafted features and the handcrafted techniques for lightweight and low cost kind of implementation, and you can also use deep learning for different other innovative applications, right? So I have given an algorithm here. I'm showing you the implementation. What I have done with the algorithm is that I have taken two images, one image, converted it to grayscale, divided it into, let's say, 16 equal parts, as you can see here in this particular figure, right? So this image converted to grayscale, divided into 16 parts, and then I have used an autoencoder, which is a neural network setup, to find out that which of these segments which I have done is more important in contribution of feature extraction from all these parts, right? So the autoencoder is giving me, let's say, 8 partitions. If I specify, it will give me these 8 partitions which are most important for feature extraction. So I will discard the rest of the 8 partitions and will extract features from only these partitions as with handcrafted techniques. So I have used here neural network for segmentation purpose, right? And then you see, if I even increase the threshold of selecting the partitions, and I will come down to 4 different parts only from where I can extract the features. You see the results here. So with color histogram, I have done no thresholding, no partitions, and all the number of features were there 64 and the accuracy was 48.6. It was much lesser. Then I have divided it into 16 parts and I have carried out the feature extraction. Then it is giving an accuracy of 69.9. Then I have come down to 50% of it. So I have taken 8 partitions and 64. And the accuracy has got a little lesser, but this is not a statistically significant difference. So with much less computational power, you see, I can have almost by and large similar kind of accuracy. All right. When it comes to that, I have used the ULBP. That is, this kind of feature extraction. When you find this, that is local binary pattern, right? So when you find this kind of feature extraction, there are 59, dimension of feature it is. So when you again use this ULBP feature and then use the fused feature, there also if you do the dimension reduction, you see you are getting by and large more accuracy than the single one, but with reduced dimension of features when you are doing the fusing. If you do a normal fusing, the dimension of feature will be much bigger. But then if you do the feature dimension reduction with this kind of a technique which I have shown you here, you will get enhanced results, that too with the help of multi-view features. So that is what is one example of an innovative use of a neural network. I was talking about representation learning. Here I have used autoencoder for representation learning of these dermoscopic images. Here you will find that the autoencoder weights are used as features, and this is being generated by the let's say the hidden layer of the autoencoder and from these particular images. All right. So this is another use of a feature extraction of the deep learning neural network. So this flow diagram has been shown that how it has been done, extracting the ROI, region of interest, with the help of the ground truth, and then reshaping it, and then rotating it by in several angles from -180 to 180 for generating more and more training data, and then using CH or that is color histogram of oriented gradients, and then autoencoder for feature extraction, and then classification with single feature evaluation and fused feature evaluation. These are the two different metrics, specificity and sensitivity, on which these things are evaluated, and you get these kinds of results. As you can see here, let me show you that once you use the fusion of features, you get much more results, compared to the single feature. That is, this is a neural network feature automated one, right? Where you have got 89%, and then fusion of org and automated feature is even more. Fusion of CH and automated feature is by and large even greater than the single feature, right? So even you see here that feature extracted with neural network is not always a panacea, not always give you higher results. It's that if you can use it as a fusion of handcrafted or neural network, it can give you even more generalization of feature. It can even provide you with higher accuracy. So you need to understand the innovative use of neural network, right? Now we move forward. That is the final words for this session is that knowledge, as we all know, is never obsolete. If you think that if you have learned image processing, that is obsolete now, if you have learned neural network, that is of no relevance now, it is not correct. Always knowledge is of prime importance, always self-learning is of prime importance. Don't always jump into asking questions to your supervisor, professor, no. You first try to find the solution on your own. The learning that you make on your own self, that is the self-learning, which is very important for a research career, which is very important for Industry 4.0 perspective, if you want to be an Industry 4.0 ready professional. And instead of getting judgmental, we need to be responsible and innovative as professionals. Don't try to get really judgmental that this is good, deep learning is good, that is bad, handcrafted is bad, or this one, or vice versa. So what you have to do, you have to find out that where to use what and which can bring out maximum efficiency out of the task which has been given to me, allotted to me. With an open mind, if we can bring disruption as technocrats and researchers, rather than getting too specific, we will definitely be able to do good work for the society and good work for ourselves. I run this YouTube channel, as I already told you, which is now here in front of you. That is Curious Neuron. If you want to get in touch with me, if you want to see some of my open access videos which are there, so you can connect me with this link at YouTube. This is what are the places where I can be you can reach me out. This is my email, rickdas78@gmail.com. This is my website, www.rickdas.com. This is the YouTube link which I have said. This is the LinkedIn and profile of mine. This is my SEM Distinguished Speaker Lectures profile. This is my Scopus and Google Scholar. These are the Scopus and Google Scholar profiles. So here also you can reach me out, and if you are really interested about what I have really done, what you can get in touch with me with the help of all these profiles. And with these words, now I would like to express my thanks and gratitude to all of you for your patient listening. And thank you, CGC, for providing me this opportunity. Thank you. Thanks a lot. Thank you very much.
Thank you, Dr. Das. If with the dear participants, if you have any questions, please write in your chat box.
Yeah, anyone, any question, if they even want to interact with me, anyone can interact with me, or else write in the chat box. I would try to respond back.
Dear participants, if you have any questions, okay,
Yeah.
hope there is no question. You illustrated the whole thing in such a lucid manner that all the participants can able to grasp all those talks, and hope the participants will enlightened. So now, so it is our privilege and great joy for me to extend a vote of thanks to the speaker and all the participants to make this morning session a success. We heartily thankful to Dr. Rick Das sir for his wonderful lucid technical speech and sharing his knowledge in the field of machine learning and image processing.
One question is there in the chat box, please.
Okay.
Professor,
Professor Hazra. One thing is that
Yes.
there are so many feature extraction techniques which I have already mentioned. Apart from this, like to have, these are the techniques which are also, which are so many in number, that you can try and test each one of it, and you will hardly get any time to test with other feature extraction techniques. But then still, for your questions to respond back, there are certain feature extraction techniques in the terms of pyramid feature extractions, right? Like if you would try to extract features with the help of p-hop, right? That is pyramid of histogram of gradient, histogram of oriented gradients. That is one. Second is that if you try to extract features with the help of different kinds of descriptors which are available, like DCT, I have already told you, if you can use fast Fourier transform, if you can also use discrete sine transform, right? So there, if you can use it in the form that, as you all know, that whenever you apply some kind of a transform, the energy goes to the extreme corner of that particular image. If you try to grasp that energy by identifying the fractional coefficients, that will become a very good feature for your work, and you can use it to even feature reduction dimension, as well as you can use it in terms of, let's say, transformational feature, transform oriented feature for your image data. One more feature extraction technique that I would suggest you is PCA, principal component analysis. If you can try that, these are all good old traditional techniques. So principal component analysis can work very well in terms of feature extraction, and you can try it even in terms of fusion with other features, and it can give you good results in terms of accuracy. Yeah. Anything else?
Any other questions?
Yeah, of course, Mr. Rahul Amin. I will share the PPT with Honorable Dr. Saurabh Dey, and I'm sure Dr. Dey will be definitely circulating it among the participants.
Yes, yes.
You know, and I'm always open to do if anyone of you are interested in collaborative research. Me, Dr. Dey, I'm sure Dr. Adhikari as well. We are always open to do collaborative research work, and we would like to move ahead with collaborations and your ideas. And I'm sure we will be able to do some kind of good contributory work as well as research publications, which will be good for all of us in terms of understanding the current scenario and Industry 4.0 trends and techniques.
Dr. Das, there is
another question. Yeah.
Yes,
Sir,
yes.
which feature extraction technique are the best for textual sentiment analysis? Now you see, if you are looking at text data is a different game altogether, right? So in case of text data, if you are really looking at it, first of all, what we need to understand that what we are doing at when the class starts, what class? Okay, let me first answer to this question. Well, text data, when you are doing, you need to understand the stop words and the stemming technique. So now, while you are importing the NLTK, isn't it? That is the natural language toolkit. So there, primarily you get the features, right? So from that primary features, if you are doing a bag of word approach, where you are actually transforming the entire data to a matrix which will give you the occurrence of the different words, let's say in that particular sentence, that will create a feature in the first place. But then at the same point of time, as I have already told you, you can use a feature scoring technique on that. If you Yeah, Mr. Gayan, please mute. You can use a feature scoring technique on that. What you can do is that with the feature scoring technique, you can have the features, almost 50% of the features, which will be good at providing, contributing to the particular classification or the prediction process of the textual data. So you can use a mix of different kind of feature scoring techniques. So some of the common techniques must be chi-square technique is there, and different kinds of statistical measures are there by which you can find. But but then still you can use features, robust features extracted even after applying the bag of words technique on the textual data. Well, see, Dr. Kotapalli Poonam Chandar. See, if you like to, identify the outliers, you straight away go for, SOM, right? So that is so with the help of SOM technique, if you use that, you will be able to identify automatically the outliers. So that will not be a big issue to identify the outliers in this case if you are using the SOM technique. One thing in this regard, I would just, for your example, I'm trying to show you, I think you will enjoy this, just a 5 minutes demo. That why I was saying in my talk that, see, nothing is important these days, you can all the time. Let's say this software is known as Orange. Probably many of you are acquainted with this. Please pardon me with my machine is so much is my screen not shared, right? So I'm showing you my screen in fact, so that you will be able to have a look. This is just a 5-minute demo which I'm showing you. So let's say you are so this is a particular kind of, let's say, data which you are having. So why I have told you that building prototypes is so easy these days, what you have to do is to generate ideas. I'm giving you an example, hands-on example. You see, if I click on this import images, it will come here at any point of time. This is just because of the slowness of my machine. Just a while. My screen is visible to all of you?
Yeah.
My screen is visible? Okay.
Yeah.
So it is here now. Okay. So as you see that, yeah. So if you see here that import images is processing. So now this has come here, right? After this, what will I do is nothing but I will let's say take one image embedding. Okay. So I have taken one image embedding here, and it will also look visible here very shortly. So So why am I saying that prototype building has gone so easy these days? You see, I have taken this image embedding particular icon. What I have done, all of you have seen, I have just clicked it, I have done nothing. It will come here. So that's why I told that at times we work in very restricted environment, that we need to be very careful about our infrastructure which we are having. Uh, so that is why, as you can see here live, that how much time it is taking. Otherwise, this machine has become a little bit slower because it has gone older too. So it will come in a while. So that I can show you an example. I was having this in my mind to show you the example, but the problem is that I am also aware of the capacity of the machine, that at times with so many applications the machines behave radically. However, so these are the images which I am importing here. So you see this folder name is image data, right? So before I import this, I would like to show you what is lying there in image data. Where is this folder? Must be here somewhere. My screen is also very clumsy because of so many tasks. It's usually Dr. Day gives me so many tasks that my screen becomes like this. Yeah, so this is what is the image. There is a very small data set which I have created. You see there are 4 categories: human beings are there, and sea beach are there, and then monument is there, and then buses are there, isn't it? Now these are the 4 categories. I would like to extract features from this. So I am importing it here, doing nothing, just importing it here. Okay. So as I told you, import images. If I click on this, so this image data is now, I am reloading it. It is showing that 40 images are already there, right? 40. 40 images are there in this box. So it is now uploaded. So what I do now, I just connect this to. Okay. So just a while, the connection will be there any moment here. So I have connected this. You see, image embedding is going on. So why the image embedding is going on, I am showing you why it is going on. So yeah, here it is. The image embedding will be there in front of you. I would just like to show you that how easy it is these days to extract any feature and create any sort of model from that. Uh, Yeah. So you see, this software has done the image embedding for me, right? Why? Because you see, in this software there are so many feature network. Inception V3 has worked now for me for image embedding. So I can do it with VG16, VG19, Painters, Deeplock, OpenFace, and also Inception V3. Okay. So I have done a deep neural network feature extraction. What I have done, I am showing you with just this. You see, if I connect this to the data table, all right. So I'm just connecting this to the data table. So these are all the features. See, from there those images which are already being extracted. So if you can see this 2047 features which are already being extracted, the feature extraction part is over now, and these are the image numbers. You see, these are the image numbers, and you know according to image numbers which category the images belong to. So even you can put it in separate folders to understand the categories. You just name the categories of the image data and put it to a classifier, and it will be classified for you. Now, for the sake of example, if I take another data, let's say, you see how easy the classification even is. So for CSV file import, let's say I have taken this. Okay, so I will take a CSV file. So this is a CSV file. Let's say what is there inside it: efficient net normalized. So some this data is there which is efficient net normalized. I will take a data.cs which is much a smaller folder, which will be easy for you to understand. So let's say I have taken this with the data table and I am connecting this. Okay. So if I connect this, these are the different these things which are there. Country name and age and this, and then finally the dependent variable, that is whether the person has purchased a product or not. Yes, no. So this is a categorical problem. So this is what I have uploaded, and now what will I do? I will choose a select columns, another this thing icon, and I will not do nothing but connect it, and then I select all the data here. You see, I am selecting all the data here with Control A. Okay, sorry, just a while. So I select all the data here with Control A. Once this is done, I enter here and I bring this to dependent variable. These are all independent variable, let's say. And now what will I do is that I will do nothing, but then I would like to select a, let's say, learner for this. Where is the learner? visualize is here, model is here. So what are the different models? So I would like to do test and score. So here I am testing and scoring, and here let's say I choose a logistic regression like that. That is a classifier all of us know. So logistic regression is chosen for us, test and score is chosen for us. Okay, so if I connect this to this, if I connect this to this, if I connect also this to this, so let's see what happens in fact. Here it goes, sorry. Just a minute. Remove. So this is the learner, if you see, and the data is also connected to this. Okay, so this test and score is giving some error because of the fact just a while. This variable is here. What is the reason of error? Let's see. Logistic regression, precision, logistic regression. Just change the, if I change the data set here, because there are three categorical variables, I need to convert them to, let's say, need to convert them with one-hot encoding. So that is not being done. So let us take the good old iris data set. Okay, so what data I have taken? I have taken this data. Okay, so based on the sepal width, the different flowers are classified. Sepal width and petal width. Okay, so if I take this data, entire data, and then now if I convert this species to the target variable, let's say. So this species is there in the target variable, which is the dependent variable. Okay, now it is ready for evaluation, and the evaluation for sure is done for us. Let's see, with holistic regression, we get 100% accuracy for tenfold cross validation. Let's say it has done it so well. So if I would like to see what has happened to this, so I can even connect a confusion matrix to this and try to see this. All the categories are correctly. See, all the categories are correctly classified. So you can see how easy a machine learning prototype building, and you can see how easy a machine learning task is by using this kind of different GUI, GUI based system. So you can understand that, right? So there is no dearth of this kind of system which are there in the market, and you can do it at any point of time. What is more important is your idea. So tools are always there, and technologies are always there. There is no point looking for being a neophyte or finding out different kinds of new techniques. But then it is more important to understand the technology. That's what I was trying to show you. I think you have enjoyed this particular software where you can do it as a just like child's play. So it is nothing, but then you can build a prototype. When you look for higher optimization, of course you need to do some more kind of things, right? Well, Professor Animes Hajra is having one more question, which I see. For microscopic images like cytology, histopathology images, which feature extraction techniques gives promising results? You see, sir, if I would know that which feature extraction technique would give promising result, I would have implemented that right in the beginning. But let me tell you, I have implemented for histopathology images. I have used ULBP, right? So ULBP for this, HOP for this, as well as I am telling you, I have used this NASNet for this, NASNet and MobiNet V2 as feature extractor for histopathological images for two different data sets. One is that Chemia data set, the another one is Breckies data set, which are very let's say popular breast cancer data set. I have also tried to use some kind of parameter tuning in neural networks to optimize the performance of the classification and the different other metrics which we have sensitivity and specificity which we have considered for this particular experiment. Yeah. Any more questions? Any more queries?
Good morning, sir. Myself, Kottapalli Punnam Chandar.
Yeah, good morning.
Sir, in this software, can we integrate any our own algorithms to get good results?
You can do that. In fact, for your algorithm, I would say that why at all you would integrate it in this software. Let's say you have created an algorithm for feature extraction. You extract the feature with that algorithm. Use that features directly in some kind of a classifier which are available in this software. You do not need to write the code for the classifier in that case. Neither you have to import anything. You can bring out the features from outside from Python or MATLAB, whatever is your preferred tool, and then use it in this kind of a software to directly get and to compare different sorts of classifiers. Your work will be much more reduced.
Thank you, sir.
Yeah, thank you. Can we use in network? Can we use in network for feature extraction? Ma'am, would you be please more explicit and elaborate with your question? Can we use in network for a neural network? What are you trying to mean, Miss Mohini Singh? Okay, yeah, well, you can definitely use that in terms of representation learning, right? So if you are keen to have representation learning with, but then you need to understand that whether the features which are being extracted are oriented towards the requirement of your kind of features which you are looking for to be inserted in the algorithm or in the learner, which I have right now shown you. So you may use any sort of network for doing that, but then that may not turn out to be a good result. So just for I told you, just for the sake of novelty, it will not be wise to spoil a problem for which you are already having some good resources present. So you can try to enhance on those resources, or you can also try to integrate your this kind of feature extraction technique into the existing resources that can well create an optimized, let's say optimized combination of traditional and new innovative, let's say new approach in terms of feature extraction. Yeah, anything else? Any more query, any more question? There is one, Khushbu Mishra. Has Khushbu Mishra asked any question? No. She has just said yes, sir. Okay, fine.
Yes, sir.
That's great. So it has been a wonderful session and
Yes.
wonderful interaction. I would like to extend my gratitude to CGAC, Dr. Saurabh Singh, and all the professors and principal present here. And of course, my gratitude to all the participants and thankfulness to all the participants for your patient listening and interactions. At the same point of time, I would be open for collaborations along with Dr. Saurabh Singh and Professor Sudeep, who is present here. So we all are welcoming you all so that we can work and brainstorm together and can do innovative things. Thanks a lot. Thank you very much.
Thanks a lot. Thanks for your good example. Thanks for your lucid representation. Thanks a lot. Thanks to all of our participants for this session. Hope there is no question, and we can end this session here. And in the afternoon session, again we will join at 2:30. In that session, Mr. Prosenjit Banerjee will be with us. He is the Director, Banking Enterprise Architecture, Oracle Singapore. We are eagerly waiting for that session. Till then, goodbye. Okay.
Okay. So we'll again meet at 2:30. Okay.